So problem number 7, when we were looking at these problems on Tuesday of last week, we were mostly using Microsoft Excel to do the calculations. So the formulas that we learned about in Microsoft Excel that were applicable to time value of money that we started off with were the present value function. I'm going to put a comment in front of that. So, and under that present value function, we enter in all the what they're referred to as arguments, right? So all of the details that make up the present value calculation that we're wanting to do are called arguments. And the first one that you put in is your interest rate. I'm just going to write the names of all of these in here. So interest rate, number of periods, payment, future value, and type. And there, so that stays visible. And so with this formula, you can figure out the present value of a single amount of money. Like, hey, if I could receive $10,000 5 years from now, or I could receive a certain amount today, which one would be worth more to me, right? So you can figure out what the present value is today of a future amount. You can also, we talked about the figuring out the future value of something using the future value or FV formula. And for that one, we can figure out what a sum of money would grow to over time. Okay. And it has a very similar format. You have the interest rate, the number of periods. I'll talk about payments here in a minute. The present value. So how much would I invest today to grow over time? And oops, there we go. Now, we mostly talked about single amounts, like, hey, what would, if I could choose one amount in the future versus one amount today, what would that be worth? Or if I put a single amount in today, what would that be worth as it grew over time into the future, right? What we did not talk about as much is what happens if there are payments over time, right? Like if I want to save on a monthly basis, $100 a month, say I start out putting $1,000 in today, and then I'm going to add in $100 per month over time. What would that grow to in the future? And that would be where this payment argument would come in. When we did the formulas last week, we put 0 in payments, assuming that there were no interim payments involved. If you enter a payment, that makes it what is called an annuity. Now, an annuity is an equal stream of payments over time. And so if you think about like, hey, if you take out an auto loan and they give you a monthly payment amount of like $400 or $300 a month for your car, that payment, that series of equal payments over time is referred to as an annuity. All right. Now, annuities can be payments out towards a loan to pay something off, or if you invest in, say, a retirement annuity, you might receive a series of payments over time, right? So any cash flow that's going out, we could be potentially a receiver of cash flows, a series of cash flows, or we could be making a series of cash flows. All right. So everything we do, we have to concentrate on, all right, is this a payment that is going to me or a payment I'm making to someone else? So, so thinking about present values, future values, and payments. All right. Payments that go out are they're negative cash flows, right? So anytime you take a payment and you put it into an investment, That's one example. So if I say, hey, I want to invest in a certificate of deposit at my bank, or I want to invest in a stock, if I'm taking $1,000 and putting it into that investment, that is considered a negative cash flow, right? I'm making a payment on a loan, that is also considered a negative cash flow, okay? Maybe I'll make that bold so we can see that that's still there and underline that. All right, so these are types of negative cash flow that we would see. So paying into an investment, a loan payment, any cash you give to another entity for any purpose is going to be a negative cash flow for you. All right. So if you're taking it and you're putting it somewhere else where you're not spending it, that's a negative cash flow. All right. Payments that come in are positive cash flows. So this could be, oops, let's fix that. Let's say that I am receiving payments on a note receivable, receiving payments on a retirement or investment, including dividends. Like, so if I'm receiving dividends from a company, receiving interest payment on a bond. So looking at this, right, I'm gonna expand this and shift this down a couple more, or another one here. So we've got a little more room if we come up with more examples here. So if I am a company paying on a bond, interest payments to bond holders, I'm a company paying dividends to shareholders, right? So you see, we could be on either side of a transaction, depending on whether we are an investor or the company receiving money that is an investment, all right? Okay, so there's some different examples. So now, so when you do these formulas here, or you're doing any kind of a time value of money calculation, you want to make sure that you're putting things in there based on whether they are a positive cash flow or a negative cash flow. And here's why. Okay. If you do not do them the right direction and you do a formula like this, let's say that I've got, I want to figure out the future value of something, right? If I put payments as positive payments and I put present value as positive payment here, that's going to imply that someone is paying me something today, and then I'm also receiving a stream of payments over time. In reality, if I'm investing something, like say I'm buying a bond, I'm probably paying out something at the outset for a present value to purchase an investment. And then I'm probably receiving a stream of dividends or interest over time for that investment. So the payment out into the investment to purchase the investment is a negative cash flow, but any payments I receive back in the form of interest or dividends are positive cash flows. I will get the wrong future value if I don't differentiate between which ones are payments to me versus payments I'm making out. Okay. So always watch out for the direction of the cash flow when you're doing these. Also, if you do them incorrectly, sometimes you'll end up with, you'll get just an error. Like if you calculate a stream, or if you're trying to calculate some of these formulas in Excel and you put everything the same direction, it'll be like, that doesn't make any sense. And it'll just be like error and it won't give you anything at all. So if you are typing stuff in here for one of these formulas using Excel, and you keep getting an error, you're probably forgetting a negative sign in one of your cash flows. So like that's the far and away the most common error I see that people make. Yeah. So you would consider that like paying. So the question was for those that are online, what if you're paying money to yourself, like you're taking money and you're putting it into another account? I mean, technically, when you're investing in something, that's exactly what you're doing. So if you're putting it into an account where you're going to leave it and have it grow over time, even if it's your own other account, that would be considered a negative cash flow. Yep. Or for the purposes of these calculations anyway. Yeah. I mean, you're getting it back, but in theory, you're losing use of it, so to speak, because you're going to keep it in your investment. Yep. Okay. So I just wanted to call that out because that is probably one of the bigger areas where people run into where they get really frustrating errors on these formulas. Um, so looking also at this under the type, right? When I talked about these formulas originally, I said, hey, we're pretty much always going to put a 0 in the type, right? For the type, what they're wanting to know is when payments and compounding are occurring. If there's no payments involved at all, in the formula, pretty much always use the type 0, which is that interest and compounding is happening at the end of the time period. Okay. Which is normally what you'd expect, right? The type 1, for if you are making payments on something like let's say I want to save money and I'm going to have an equal stream of payments of $100 starting today. I'm going to put $100 into an account. If I'm starting with my payments today and not waiting a month before I make a payment, that's when you would use the type 1. So usually you're using that in savings scenarios where I'm going to start off opening a checking account and putting $100 in it today. And basically all that does is it tells the formula that we should accrue interest on our first payment that we make. Okay. Now, one thing to watch out for also with number of periods, if you have payments associated with an investment or a stream of cash flows, the number of periods is the number of payments that you're making, whether you're starting today or in the future. So, arrow here. I would put or equal deposit. So that payment function can be like, oh, I'm paying for a loan, or it could be what I'm paying into an investment or savings over time. Okay. So it's not necessarily typically, and the way this formula works, it's very flexible. It can determine if it's a payment to me that I'm receiving or a payment that I'm putting into an investment or savings over time, depending on which way the cash flow is going. So if it's a negative payment, that's indicating I'm either making a payment out to a loan or I'm making a payment to save in an investment. So putting cash out into something else. There's lots of little details as far as how these payments work. And by the way, all of these notes here are that we're making, they're actually relevant whether you're using the Excel formula or whether you are using other methods to do the calculation, which we'll learn how to use a table to do this also shortly here, because the homework likes to have um, you use the tables. So now we're going to walk through, okay, what does this look like if we are using tables to calculate things? So we're going to go through that problem number 7 that I had to open up here. Maybe not. Let's see. Why do I have a different problem here? Arnold Corporation. I'm in the right one, right? Oh, I'm in the homework. That's why. Okay. Sorry. Why am I showing the wrong one here? Let's close this. Go into the simple problems, not the homework. Apologies. So actually get the correct problem I'm looking for here. All right, there we go. That's the one I wanted. Okay, so when we are looking at these problems, right, they assume that value of an investment is going to grow over time, right? So if we start out, I'm going to draw, oh, that was the world's worst graph. Like, let's say this is the amount that I put into an investment at the beginning. We expect that over time it's going to grow. Let's pretend that's a straight line. I'm using a pad here instead of a mouse, so it's harder to draw a straight line. Future values are typically assumed to be higher than present values, right? So present value would be like in this example, oh, what am I investing today? And then the future value is what it's going to grow into. It grows over time. And it's going to grow here based on compounding and interest rates. All right. That's important to remember, just like it's a very simple concept. It seems obvious, but it will help you if you are trying to figure out which table you need to be using to calculate something, right? So if I have a future value number and I want to know what that is worth in today's dollars, I'm going to be reducing it down to less than what it is today. That means that the table that I'm going to be using should have a function that is going to be less than 1 because I'm going to be reducing it to a fraction of itself, right? Whereas if I have a present value amount today and I want to know what it's going to be worth in the future, I should be looking for a number that is going to be more than 1, probably multiple times more than 1 to figure out what that will be worth in the future. So if you have to use these tables, got tables here that give us basically a multiplying factor that helps us with the formula that is involved. So if you remember, I talked about last week how the growth of an item can be calculated by taking the present value times 1 plus the interest rate to the power of, let's see, where's the power of E. E being the number of time periods, or actually, let me make this N for number of periods to be consistent here. That is the future value calculation there. And if we take that same formula, if I take this future value, let's do some algebra here, right? If I take this amount and I divide both sides by this exact amount here, the 1 I, this is going to be painful if I'm just going to put dot here. indicate that I'm going to cancel that out, right? By dividing both sides by that amount. And calculate the future value by taking, or I'm sorry, the present value by taking the future value and dividing it by 1 plus the interest rate. It's a parentheses. It's a very ugly one, to the power of n. Okay. So more clearly then, if I put this in types terms, it would be future value divided by 1 plus I to the power of n equals present value, right? So those are the same formula, just rearranged to be like, am I solving for present value over here, or am I solving for future value over there? Now, I do not want anyone to manually do these calculations because the rounding and whatnot associated with them will get you when you're doing homework or whatever, and it'll make you very upset. But I'm calling out the formula because I want people to know how they interrelate with one another and what is the underlying factor that is in this growth, right? So that's kind of a repetition of something I talked about the other day. But going back then to that problem we were looking at, have tables that actually calculate that 1 plus interest rate to the power of n factor for us, whether it's the actual factor. So 1 plus interest rate to the power of n. That is like the worst writing ever. I'm so sorry. I do much better with a regular mouse. Or that would be like the future value factor that is on these tables. If I take that and I do 1 divided by that amount, it's the present value factor that is on these tables. And so it calculates this for you in each of these with the percentage rate on top and the number of periods on the side. Okay. So they showed that kind of in the video that we watched on Thursday, I think, last week. So basically, this problem is just going to walk through using these tables as a group here. So the first problem that we have, to do an example, we're going to calculate the present value of some principal. And so we've got a market interest rate of 8%, and Arnold Corporation is issuing $200,000 of 6% 10-year bonds payable. All right, the bonds pay interest semi-annually. So looking at this problem then, if they're paying interest semi-annually, what is our n for our number of periods here? 20, right? So 10 times 2, so 20, right? And then we have to also think, though, what is our interest rate going to be for our interest payments? If we have interest here that is going to be paid twice a year, to calculate interest payments, what is it going to be? Yeah, it's going to be 3%, right? So that's to calculate the interest payments. So our interest payments are going to be, whoops. You know, I'm going to save us all this pain and just, I'm going to make this window smaller, and I'm going to put Excel on the right so I can just type it. It'll be clearer, faster, and more readable for everybody if I just do it that way. All right. Usually when I do Zooms, I probably would have been better off doing this from my desk because I have a huge screen and a real mouse. But Here we go. One of those things would be a little bit easier to do on a board. All right. Okay. So our n equals 10 times 2 equals 20. So interest payment is going to be calculated at 3%, which is the 6% divided by 2 payments per year. Okay. So if we have $200,000 worth of bonds, our interest payments are going to be 0.03 each, 3%. So that is our semi-annual interest payment. Okay. And we want to know what is the present value of the bonds at the issuance. All right. So here's an interesting thing about bonds. All right. I started to talk about this a little bit the other day. But they typically are getting issued based on the interest rate that the market demands. So the price of the bond shifts based on the interest rate that is demanded by the market. So they pay out interest based on their contractual amount, but the value of the bond is based on market rate. And by shifting the cost, the initial cost of the bond upwards or downwards from its issuance value, how investors, the market kind of controls how much return that people will get on those bonds. So we've got a $200,000 value here. And if we, so that $200,000, right? People invest in the bonds, they buy the bonds. At the end of the life of the bond, they will get repaid that $200,000. So with respect to a bond, the face value is actually the future value that they will receive at the end of the bond. Because that is a contractual payment as part of the bond's terms. All right. So remembering back to Thursday, we talked about how the bonds have a stated interest rate that will determine the interest payments you would receive over time. It has a principal amount that they have to repay at the end of the life of the bond. But what the bonds sell for at the beginning is actually based on the market rate. So if we go out here, what we want to know is what would we pay for this bond today? Okay. That's going to be a present value that we're going to calculate. So we're going to look at this present value table. We're calculating the value of the principal here. So we're going to go out here and we need to look for 20 payments and if we scroll down here, let's see, oops, hold on a second here. What was our market rate of interest is 8%. And we want to go, and because they get paid on that twice a year, we're considering the growth down here 4%. So 8% divided by 2 is 4%. So, oops. So, so present value, I'm just going to make a note here for you. Present value based on the market rate of interest, the number of and the interest, market rate of interest per period. Okay. So if we look here at 4%, so 8% divided by 2, semi-annual payment. Scroll down to 20 periods here. We get 0.456 on this table, okay? That means that 4, 5, 6. Oh my gosh, 4, 5, 6. I can type. All right. So what people would pay for this today is going to be 200,000 times 0.456, which is going to be $91,200. Okay. So they're paying substantially less than what they would get at the end because they need to get an 8% return over 10 years, compounded twice a year. And that makes sense because on that drawing, right, when we showed the growth rate, the present value is going to be less than the future value. So we need to make sure that that it's discounted down. All right. And if you look here, by the way, look at the future value table here. See all these numbers are more than one. That's because it's calculating growth into a larger amount in the future. If you ever get stuck on like, oh my gosh, which table am I supposed to be using here, present value or future value? You can sort of back into it that way, being like, okay, what do we expect to happen? It's going to grow over time. All right. Now the next one, calculate the present value of the stated interest payments. So this one is going to be an annuity, right? So anytime we have a stream of payments over time, the value of a stream of payments or an annuity, let me pull up a slide here really quick on this to walk through. Here. So, find the beginning of that here. We went through that already. Well, an annuity is and I was hoping there'd be, oh, there it is. Okay. All right, here we go. Bigger. So an annuity is a stream of equal payments over time, right? So here is an example of an annuity calculation where somebody is receiving a stream of payments. So we're going to receive $2,000 at the end of each year for 5 years. All right. So the present value of that over time is actually going to end up being, so the $1,000 received in 1 year is an individual future value, right? So if we were to discount that back by 1 year, we would take the present value of this amount discounted back 1 year plus the present amount of this amount counted back 2 years plus the this amount discounted 3 years, this amount discounted 4 years, and this amount discounted 5 years. So the present value of a stream of payments is the individual present values of each payment added together. So the present value table of an annuity calculates what a stream of payments will be worth in today's dollars. Okay. So going back and thinking about that, all right, let me get my fill back here. We have an example here where we are going to calculate the interest payments on a series of bonds, or on the series of payments, the interest payments we would receive over time. So when we were up above here, I said, okay, our interest is always calculated based on the stated rate associated with the bonds. So when they say we issue $200,000 of 6% 10-year bonds, that means that they're making payments to us for 10 years. The payments are semi-annually, so they're going to make a series of 20 interest payments to us over time for 6% annually or 3% every 6 months. Okay. So we calculated out our semi-annual payment here. Down here, they're walking through this again. They're saying, all right, they're having us recalculate the payment here by taking the $200,000, multiplying it times 3%, which is this $6,000 we already calculated. And then they're going to calculate that times to figure out what is the present value of an ordinary annuity of 1. Okay. So looking at that, I'm going to head out here and let me see here. This is again calculated at the market interest rate. So anytime you're looking up things related to a bond on here, you're going to look it up based on the market interest rate because people are trying to seek that market rate of return. So that will determine the value here. So looking at the 4% column, which is the 8% divided by 2, we have a factor of 13.59 here. So we're going to go ahead and plug that in. Whoops. So taking $6,000 times 13.59, we get 81,540. So the value of a bond is equal to two things. Sum of the present value of the principal plus the present value of the payments. Okay. Oops. Okay. Comment there. So here, our present value of our principal was the 91,200, and the present value of the stated interest was the 81,540. So adding those together gets us 172,740. So that's what we would pay to today in total for the value of the bond and the stream of subsequent payments that we would receive over time. Oops. So on interest, payments always at stated rate for the bond, and table values always use the market rate. Okay, so when you're looking up the amount on the table to figure out the present value of either the payments or the principal amount, you're going to be looking in the column for the appropriate market interest rate divided out into however many payments per year there is. So if we had been looking up the same problem, by the way, we would have, if it was an annual payment instead of a semi-annual payment, then we would have looked in the 8% column at 20 for both the principal value and for the payments. Okay. Okay. So that's not a problem. Let's see, and we did problem number one. So yes, yeah, go ahead. Yep. We looked at about 4%. Yes. Market. Yes, in both cases. Yep, in both cases. Yeah, so with the time value of money part, right, with bonds, the only thing you actually use the stated bond interest rate for is to figure out the dollar value of the payment. But the present value, like, so if we're doing a formula out here in Excel too, going back to this formula, if we were doing a bond, if we were gonna, let's just do this right here. I'm gonna type this exact problem we just did into Excel and show you what that would look like. Okay, so to figure out the present value, what we would pay today for a bond that is worth $200,000, we're gonna do this based on the market rate per payment period, which is gonna be the 4%. So 8% divided by 2, right? And then our number of periods is going to be 10 years times 2 payments per year, or 20, right? Um, the payment amount that we're going to have for a stream of payments is going to be, let's say I'm the investor here. So I'll say I'm receiving interest payments, right? So I'm going to receive a $6,000 interest payment for each of these 20 semi-annual periods. The future value that I'm going to receive is going to be the 100,000, and my payments are gonna be at the end of the period here, right? So I would have to pay then 172,819 compared to what the table calculated, which was, oops, the table calculated 172,740. So it's different due to rounding by about $100 because every single calculation is rounded, but it will get you very close um, um, in terms of a like almost $200,000 asset and stream of payments. Yeah. Yes. So I believe for the exam, it's going to be, you're going to want to use the tables for that. Yes. Yep. The fine. Yes, the tables will be within Pearson. So they open those within like the window. So the tables will work. Yep. When you click on them, they don't form a true pop-up separate window. They are like a display within that window. So the pop-ups will work. Yep. Just like I'm trying to think, were there any problems where you had pop-outs like that in the last exam? I'm trying to think if there were. Okay. Yeah. No, they should work though. Yes. Uh, yes, actually you could. They might be really large. So if you want to have the tables printed out so you don't have to look them up on your screen, let me look into if I can print those out for you. Just because then everybody would just have them. Or let me take a look at what format the problems will be in to see how that will work to just make it more smooth for people. Because if they're going to show you like a screenshot and you just have to grab the right one off of the screenshot right in the question, then it'd be kind of a moot point. The thing that's a bummer here is that like the newer version of this text has an integrated financial calculator right in it. So you can just enter in like the components and calculate it out. But this older version of the textbook that they're using doesn't have it. But yeah, okay. So I will look at that for the exam purposes. Okay, so But yeah, so we did problem number one in the sample problems last week, right? As a group, we divided that out and did it. Did we not? Or not? Or maybe we didn't do that one actually. No, I bet we didn't. Okay, we just did some of the handout ones. Okay. So, let's go ahead then and start looking at some of these other problems we've got out here in the sample problems. All right, so we have got, I'm gonna make this narrower again so we can read. So we've got a grandfather who wants to share some of his fortune with us, yay us. And he offers to give you money under one of the following scenarios. So we've got a couple different scenarios here. $87.50 per year at the end of the next 6 years. $49,650 in a lump sum now, or $100,450 in a lump sum 6 years from now. So how can we get these all to an apples to apples comparison to figure out which one is the best value for us? I would say, so this one right here, the second option, is present value, what that is worth today. So if I have this amount today, that is a present value. And so let's do the present value for each of these. So this one's easy. We don't have to do any math for it. 49,650. That's 49,650 handed to me today is worth exactly 49,650. That's what it is. But so for this one, what type of situation is this number one here? 87.50 per year at the end of each year for the next 6 years. What do we call that? Yeah, it's an annuity. I'm seeing some people mouthing it, so I'll just say it out loud here. So this is an annuity. So we want to calculate the present value of an annuity of 87.50 per year for 6 years. All right. So we've got n equals 6 here, and the payment equals 87.50. So to calculate that, we would take that 87.50 and multiply it by the amount from the present value of an ordinary annuity table. So let's look at that really quick here. So it's not the present value of $1. The present value of $1 is where we just take one future amount and convert it to today's dollars. So we want to do the ordinary annuity one here. And they're telling us down here, assuming a 6% interest rate. So let's, and it's 6 years. So we've got 6% for 6 years. So 4.917. Okay. I did the right column, right? 6% for 6 years. Okay. So 43,023.80. So if we round that to the nearest dollar, it's going to be 43024. So by the way, make sure so that you know that you're getting the right column. The amount that you have in here should be less. So when you find your interest rate and you find your number of periods, the amount that where that intersects should be less than your N because you're discounting that payments back. Okay. Now, present value of scenario 2, 49,650. We already calculated that. And then the third scenario is $100,450 6 years from now. So this 100,450 in 6 years is a future value, and we want to discount it back to today. So since this is just one amount, we'll use the present value table here. So we're going to again look at the 6% discounted down to 6 years where those intersect. So 0.705 times the amount we would receive, which is, hold on here, the 100,450. So 78,170, so rounded down. So 78,170. Okay. So which one is the best option for us here? Three, right? It's got the best present value. Kind of stinks because we have to wait 6 years to get it, but it's like more than it's like $21,000 more than the next best option as of the end. So if we can be patient and hang for a while, we'll end up with almost a third more money at the end of the 6 years. So scenario 3 looks like it's good. Its present value is the highest. All right. Now, what if we changed it to a 12% discount rate? All right, let's go back to our tables here then. We're going to look at 12% for 6 years. So 0.507. That takes it down significantly, right? And then for this one, for the annuity, 6%. I did 6% on that one, didn't I? On that last one? Okay, now I got to go back and look at it again. Or no, it's 12. Sorry, we're looking it up at 12% again. So 12% if that's our interest rate this time for 6 years, that's 4.111. So present value 35,971. Again, 49,650. And then 59,28. So, so did that change our preference here? I don't think so. I mean, if we're just doing it based on dollars, it would not change it. So I'm gonna say though, I know, so all of these questions, the which one would we prefer? The answer is 100% in the textbook going to be based on which one is worth more dollars, even if the difference is like $100. Okay. I'm going to tell you right now that if it was based on an actual 12% interest rate, and I knew I could get 12% on it, I'd probably go with the 49,650 just because a lot can happen in 6 years. But for the sake of this problem, we're choosing whichever one has the higher present value today. And honestly, 12% is kind of a high interest rate to guarantee. The odds of actually getting that consistently for 6 years are not awesome. And seeing that the spread gets wider between, the lower the interest rate that you get, I would probably option 3 would be more reasonable. If it was a lower interest rate and we only had the spread, though, I'd be kind of like, I don't know. Okay, so that's problem 1. Let's go to problem 2. All right, so here we've got a bond example. On December 31st, when the market interest rate is 12%, Benson Realty issues $600,000 of bonds, 9.25%, 10-year bonds payable, and they pay semi-annually. All right, so N is going to be what? What is our N for number of periods? 20, yeah, 10 times 2. And then our interest payment, which is the only thing we're going to use the bonds stated interest for, is going to be 0.0925 divided by 2. So the annual interest rate of 9.25% divided by 2 times the 600,000. That's what they have to pay twice per year, right? And then the future value of this bond is going to be the $600,000. And our interest rate for I'm going to put this in quotes. I didn't want you to make that. My gosh, it keeps wanting to capitalize it. Let's put I. There. If I type it without quotes, it doesn't try to capitalize. Autocorrect. All right, so the interest rate that is applicable here is going to be the 12% or 0.12 divided by 2 because of 2 payments per year. So market interest annual divided by 2 because it's semi-annual payment. Okay, so then interest semi-annually. So determine the present value of bonds at issuance. So go ahead and do this one. I've given you the tools, and then I'll tell you the answer here in a second. Here. Okay, So the total we pay is going to be the um, um, present value of the principal. So this is the, put this here so you can see my formula. The $600,000 times the present value factor that I got from the $1 table in the 6% column and 20 periods. And then this one down here is the payment amount that we calculated, the 27,750. And this is the this table down here. Let me insert an extra space here. So present value of ordinary annuity of $1. And so, and that was again 6% and 20 periods for those. Adding those together gets us 505,493. Okay. Next question. All right, we got a saving for college example. Also, you could say you're saving up to buy a car, or you're saving for retirement, or you're saving to pay for a vacation or something along those lines, right? All of these are kind of similar. And they're saying we're going to save money for college. We can save $5,000 each year for the next 4 years from a part-time job. If we're able to invest at 6%, how much will we need? All right. So I equals, I want this to be the 6%. And the next 4 years. Okay. So N equals 4 years. It's going to put that $5,000 in once a year for 4 years. All right. And so, how much will he have when he starts college? So what type of problem are we solving here? What are we going to solve for? Future value, yeah. And that's going to be, what is it going to be, a future value of a single amount or an ordinary annuity? Do we have single or multiple? Do we have a series of deposits that are going to get made, or do we have a single amount that's going to get deposited? So we have a series, right? So this will be, that's going to be the table we're going to use. Whoops. Take away the equal sign. It doesn't think that's a thing. So just like the present value of a series of payments is the sum of the present values of each of those, the future value of a series of payments is like, what would each individual payment grow to over time? So if we have payments that are made for, say, 3 years, and we want to know what it's worth in year 4, this one is going to be growing for 1, 2, 3 years. This one's going to grow 2 years, and this one is only going to grow for 1 year. All right. In David's case, David's going to pay, say, $5,000 per year for 4 years. So and then presumably, when this last $5,000 is saved, that's when David goes to college. So this last one, if it's deposited and saved up at the end of the year, it will actually not have any growth because he's going to be using that potentially right away. Because we want to know, what is this going to be worth when he starts college here? So this one will grow for 1 year, 2 year, and 3 years. regardless, we're going to use this future value of an ordinary annuity table, which will calculate up that growth for us. So we're going to take the principal and we're going to say, let's see, he's got 6% per year for 4 years. So 6%, 1, 2, 3, 4, 4.375. The factor is 4.375. So 6%, 4 years. So we would take the factor and multiply it times the amount of the payment that he's going to make. So 5,000 times 4.375. And that's going to get us to 21,875. And let's see here. So we've done 1 through 3. And 7. All right. So probably what we'll do is we'll do 4, 5, and 6 on Tuesday of the last week. I'll extend the homework for an extra day. Some of the stuff in our chapter 9 for managerial is actually like overlap of exactly what we've been doing in here. So we're just going to kind of continue on with this. I'll update the due date accordingly, and then I'll kind of look at how many problems I have set up for that last week to make sure we can get those all in. But yeah, so question, and I'll extend the sample problems obviously too. Anybody have any questions? All right, we'll wrap on that. Everybody have a lovely Thanksgiving.